Hi, this time we will discuss about the angle of intersection. The angle of intersection of two curves at a common point P, quantity P theta, not the pole, is given by tangent of angle of intersection is equals to tangent of radius vector sub 1 minus tangent of radius vector sub 2 over 1 plus tangent of radius vector sub 1 times tangent of radius vector sub 2, where the radius vector sub 1 and radius vector sub 2 are the angles from the radius vector OP to the respective tangent lines to the curves at P. See figure 41 to 6 for the illustration. This formula follows from the trigonometric identity for tangent quantity of radius vector sub 1 minus radius vector sub 2, since the angle of intersection is equals to radius vector sub 1 minus radius vector sub 2. Example: find the angle of intersection of the following curves. The P is equals to 3 cosine theta and P is equals to 1 plus cosine theta. Solve 3 cosine theta is equals to 1 plus cosine theta for the points of intersection, obtaining 3 halves and pi over 3 and 3 halves and 5 pi over 3. The curves also intersect at the pole, so the theta here is pi over 3. For P over 3 cosine theta, first we'll solve for the first equation of the curve, which is the P is equals to 3 cosine theta. We'll differentiate it and we'll obtain P prime is equals to negative 3 sine theta. So next, we'll solve for the radius vector sub 1 using the formula tangent of radius vector is equals to P over P prime. So tangent of radius vector sub 1 is equals to 3 cosine theta, which is the value of P, and negative 3 sine theta is the value of P prime, obtaining negative cotangent theta. Since we have the value of the theta, we'll substitute it. So tangent of radius vector sub 1 is equals to negative cotangent pi over 3. So the tangent of radius vector sub 1 is equals to negative 1 over square root of 3. Next, we'll solve for the second equation of the curve, which is the P is equals to 1 plus cosine theta. We'll differentiate it, obtaining P prime is equals to negative sine theta, and then we'll solve for the radius vector sub 2 using tangent of radius vector is equals to P over P prime. So tangent of radius vector sub 2 is equals to 1 plus cosine theta over negative sine theta, obtaining negative cotangent theta. So we'll substitute the value of theta. Negative cotangent pi over 3 is equals to negative cotangent pi over 6. So the tangent of radius vector sub 2 is equals to negative square root of 3. Since we have the values of the tangent of radius vector sub 1 and 2, we can now solve for the angle of intersection using the formula of tangent of angle of intersection is equals to tangent of radius vector sub 1 minus tangent of radius vector sub 2 over 1 plus tangent of radius vector sub 1 times tangent of radius vector sub 2. We'll substitute each value, so the tangent of angle of intersection is equals to negative 1 over square root of 3 minus negative of square root of 3 over 1 plus negative 1 square root of 3 times negative square root of 3. So the tangent of angle of intersection is equals to 1 over square root of 3. So the angle of intersection is equals to tangent inverse 1 over square root of 3. We'll obtain pi over 6. So, we'll convert it into degrees. We have 30 degrees. So, at points of intersection, 3 halves over square root of 3, 3 halves, and pi over 3, and 3 halves, and 5 pi over 3, the angle of intersection is 30 degrees.